Welcome back to the Datarekha audio guide. I'm Diya.
And I'm Arjun. Today, a single retrieval trick that cut Anthropic's search failures almost in half, and why most teams who do RAG have never turned it on.
Set the scene for me. Basic RAG works in the demo. What actually breaks when real users show up?
Three things, all at once. Exact match queries miss. Someone pastes an error code and gets nothing. Paraphrased questions pull the wrong page. And worst of all, the chunk that does come back is missing the context the model needs to answer. The whole thing falls off a cliff.
Walk me through that last one because it sounds the most subtle.
It's the root problem. Picture a chunk that just says the company's revenue grew 3% over the previous quarter. On its own. Which company? Which quarter? It's meaningless. So when you embed it, it lands in this generic small percentage growth neighborhood of the vector space, nowhere near a query like Acme Q2 2024 revenue.
Because the chunk lost everything that made it findable the moment you cut it out of the document.
Exactly. That's the disease every other RAG trick is treating a symptom of. And Anthropic's fix, they call it contextual retrieval, is almost stupidly direct. Before you embed the chunk, you have a cheap LLM write a one-line summary that situates it. This is from an SEC filing on Acme's Q2 2024 performance. The prior quarter's revenue was $314 million. Then you glue that on front and embed that.
So now the chunk carries its own context. But hang on, an LLM call for every single chunk in every document? That's got to be brutally expensive.
That's the objection everyone raises. And it's where the cleverness is. You use prompt caching. The whole document becomes the cached prefix. You pay for reading it once, and only the little chunk varies between calls. Anthropic measured it at about $1 per million document tokens on a haiku class model. Basically free for what you get.
And what you get is the part that made me sit up. Those numbers are huge.
They're unusually big for one technique. Naive embeddings failed about 5.7% of the time. Add contextual embeddings plus a contextual keyword index, and it drops to 2.9, a 49% reduction in failures. Bolt re-ranking on top, and you're at 1.9, 67% down.
You keep saying keyword index alongside embeddings. Why both? Isn't semantic search the whole point?
Because dense embeddings are brilliant at meaning and terrible at exact strings. Search for an error code like TLS_cert_ expired semantically, and the model turns it into a vague, arrow-shaped vector. You get back generic networking chunks. Old school BM25, the keyword approach, nails it because it indexes the literal token. You want both, and contextualizing lifts both at once.
So if I run to retrievers, I get to ranked lists. How do I merge them when their scores are on totally different scales?
You don't even try to reconcile the scores. There's a beautiful little method called reciprocal rank fusion, RRF. For each document, you add up 1 over 60 plus its rank across both lists. It only looks at rank position, never the raw score. So you never have to calibrate cosine against BM25. A dog that ranks high in either list bubbles up. High in both. It dominates.
Clean. And that's the part you said is always on?
One extra index, a few milliseconds, 10 to 20 points of recall. Yes, always on. The whole pipeline is layers like this. Contextualize offline. Retrieve with both. Fuse with RRF. Then a cross-encoder re-ranks the survivors. A cross-encoder reads the query and candidate together and scores relevance precisely. It can't replace retrieval because it can't pre-compute. But re-ranking 50 candidates is cheap, and the precision jump is real.
Let me push on one thing that bugs me. Embedding the user's question to match answer chunks feels backwards. Questions and answers don't even share words.
That's a genuinely sharp catch, and it's a real asymmetry. What's the refund window? And the policy line customers may return within 30 days, share 0 words, and live in different regions. The fix is almost cheeky. It's called hide. You ask a cheap model to hallucinate an answer to the query, then embed that. It doesn't need to be factually right, just answer-shaped. And answer-shaped things embed near real answers.
So you deliberately generate something possibly wrong just to fish in the right pond. I love that. Do you do it on every query?
No. And that's a key piece of judgment. Rewriting helps the hard 20% and hurts the obvious 80%. So production systems gate it. A little router tags the query as lookup or complex. Lookups go straight to retrieval. Only the hard ones get hide. You save latency and money without losing the recall that matters.
One last gotcha. Because this is the kind of thing that bites you in production. If retrieval gets really good, can't a bad actor just craft a chunk that ranks perfectly?
And that's the insight I'd want everyone to leave with. Retrieval quality is not evidence integrity. A poison chunk can rank first precisely because it was crafted for the query. Then it either feeds the model a confident false fact or acts as a hidden instruction. So you govern who can write to the corpus, keep authorization outside RAG, and treat every retrieved passage as untested data. A perfect retriever that fetches a lie is still a problem.
So the takeaway in one line.
Stop shipping dense-only retrieval and calling it done. Contextualize your chunks. Retrieve with both meaning and keywords. Re-rank. And never confuse it ranked high with its true.
The cheapest win in RAG is the one almost nobody turns on. That's the Datarekha audio guide. See you in the next one.